So just to kind of revisit a little bit this idea of effective latitude, because that wasn't listed as one of the 5, but definitely there is an effective latitude on surface temperatures. In general, the closer you are to the equator, the warmer it is, and as you go poleward, it gets temperatures generally decrease. And I'm going to show you something kind of similar to what I showed you before, with kind of a wandering hot spot throughout the year. The isotherms, the warmest temperatures tend to shift south in January, and then they tend to shift north in July. And also when you look at kind of the global temperatures in January and July here in a minute, be sure to kind of look at the coastal regions and to kind of see how the oceans have a moderating effect on the coastal regions as opposed to those locations inland. One last thing. Don't forget we talked about the effect of the temperature of the ocean current that's affecting a particular coastal or maritime location. It makes a difference. For instance, classic is in North America here. We tend to have the Atlantic Ocean off our coast tends to be warmer than the Pacific Ocean. Okay, so here is, looks like it's in January. And I mentioned kind of the wandering hot spot. I think he even kind of threw out the term at you, the intertropical convergence zone, that kind of gets something global circulation going. We're going to call starting with the Hadley cell later on. But can you kind of see this is kind of the warm spot. And these isotherms, remember what an isotherm is locating, connecting locations with the same temperature. So, and you can kind of see, I'll go ahead and pull up pull up July here. And so in July, you can see the hot spot, the isotherm kind of wander definitely north. And the hottest spots are where? The continental or inland, aren't they? Notice that's the hottest spots, even with the wandering intertropical convergence zone. Just to kind of follow that up then, we talked a lot about the annual temperature ranges. So remember what that would mean is taking the hottest month and from that subtracting the coldest month temperature. So this 3 degrees here, it means all locations on this line and inward have 3 degrees or less is the difference between their hottest month and their coldest month. So we'd say that throughout the year, this around the equator, check it out, it tends to be, their dead of winter is very similar to their dead of summer. That's what that means. The annual temperature range is very small. Notice that the annual temperature range is greatest over continents. Let's look at, I don't know if you can see it very well, but this is North America, and here is South America. So over the continents, for instance, over the continents and getting up north. So here we are in Canada, and their temperature swing throughout the year from summer to winter is 35 degrees. Up here, even farther north, 45 degrees. And I think it kind of maxes out. Oh my gosh, this is over here in Siberia, in Asia, China-ish. Look at the temperature swings here. Again, they would be greatest over a continent. This is 60. So the swing between summer and winter is 60 degrees. That is crazy. One of the things you might notice is if this divides between the northern hemisphere and the southern hemisphere, down here in the southern hemisphere, even towards their poles, which we tend to get more temperature swings as you go towards the pole, they only get a 10-degree swing. Because remember, one of the things we know about the southern hemisphere is there is less water, less large bodies of water. I'm sorry, I said that just the opposite. There is more. Oh, goodness. The southern hemisphere is kind of like a water world in and of itself. So the fact that there's more water means that it's stubborn to heat up and stubborn to cool down. Thus, the annual temperature range is less.